I am Dr. Ravi Kumar, Associate Professor, Department of SC, Ministry of Aeronautical Engineering. As part of second section, problem solving, today I am going to explain about the problems in multiplexer and demultiplexer. Basically, we know that what is multiplexer is also called as data selector, also called as parallel to serial converter, and then the many into one. So this is a simple complex combinational circuit. We know that from the fundamental basic principle of the multiplexer. Multiplexer is a combinational circuit which gives the based on the control signal, the one of which of input is passed to the output. So it has basically 2 power n number of inputs under where n is the select lines and these are the select lines, and then only one output. So the general representation of the multiplexer is 2 power n by 1, where small n represents the number of select lines. These are the select lines. It may be n select lines, 2 power n inputs. We can also call it as data inputs. Data inputs and one output, single output. Always remember that in multiplexer we can have only one output. If you see the demultiplexer, this is quite opposite for this diagram. That is, input is single input, like whatever the data serially come from the channel, that's single input, and we will distribute it to many outputs based on the select lines. Here it is n select lines and 2 power n outputs. This is called demultiplexer. Demultiplexer. So we can generalize the expression for this demultiplexer is 1:2 power n, where 1 is the input, single input, the channel is single, and then these single serially the bits are coming. These serial bits selected to corresponding among 2 power n among outputs based on the selected lines. Let us see problems regarding to this multiplexer and demultiplexer. Basically, the simple question is draw or implement 2 power n by 1 multiplexer by giving n select lines, so that we can take that 2 power n inputs and n select lines. Now the Boolean function equation for this mixer is that if you take the y is the output, so it is like a SOP form, SOP expression. There are 2 select lines or 1 select lines. For example, 2 select lines. We can take that S1 and S0 are the 2 select lines. So we can have the expression is like this: S1 bar, S0 bar. If it is true, then I0 is selected. S1 bar, S1, I1 is selected, plus S1, S0 bar, I2 is selected, plus both are 1, S1 and S0, I3 is selected. So like that we can have a mathematical like a Boolean equation for the 4 by 1 multiplexer. So based on this we can see some simple problems on multiplexer and demultiplexer. We may focus on multiplexer. Implement higher order multiplexer using lower order multiplexer. Higher order multiplexer means here, for example, 16 by 1 multiplexer, implement a 2 by 1 multiplexer. Here it is a higher one is 16 by 1, and with the help of simple basic multiplexer is 2 by 1. So let us see these kind of problems. Construct a higher order multiplexer using lower order multiplexer. There are simple steps to implement. So actually we this is a one type of shortcut method to find out the higher order multiplexer using lower order multiplexer. That is given by some problem. Let's take this some problem like construct a 16 by 1 multiplexer using 2 by 1 multiplexer or 64 by 1 multiplexer using 2 by 1 multiplexer. Let us see that first one. What is construction of 16 by 1 multiplexer using 2 by 1 multiplexer. This kind of problem can be simply solved by taking this example of expression. Find out how many number of 2 by 1 multiplexer required to find to design or to implement a 16 by 1 multiplexer. So by taking this simple formula, so we can find out the number of multiplexers, 2 by 1 multiplexers. For this problem, basically it is a 16 by 1 multiplexer, means we can take a 16 and divide by the minimum multiplexer is nothing but 2 by 1 multiplexer. If you divide it by this 2, you will get some 8, and then again take that 8 divided by the 2 by 1 multiplexer like 2, you will get 4, and take that 4 divided by 2, you will get a 2. It is a 2. It is a minimum multiplexer which we need to going to be implement. So on this successive division till the minimum multiplexer, getting minimum multiplexer. This is size for 2 by 1 multiplexer. So then we can add all the questions like this one 8 plus this second one is 4 plus 2. So you will get the answer is, again if you divide this one, what is the minimum value is 1. So you will get this one remainder is quotient is 1, and then we can get 8 plus 4 12, 12 plus 2 14, 14 plus 1 15. So you will get 15 number of multiplexers are required. And if you see this one, for the second example, how many number of 8 by 1 multiplexers are required to design 64 by 1 multiplexer. Take the given multiplexer 64 divided by to what multiplexer need to be designed is 8. So divided by 8, you will get 8 and again take this 8 divided by 8 by 1 multiplexer, you will get 1. So that the resultant value is the first one is 8 plus second one is 1, so that you will get 9 muxes are required. Here it is 15 muxes are required. Okay. So, and also for the 2 by 1 multiplexer, this general equation for this n variable multiplexer. So 2 power n minus 1 multiplexers are required. So here it is n is nothing but 2. The minimum is 2. Say what is the power of 2 in the 16? So 4, which is if you substitute n is equal to 4 minus 1, which is equal to 15. So it requires 15 number of multiplexers are required. Let us see that those multiplexers how to implement with the help of 15 multiplexers in the 16 by 1 in order to implement 16 by 1 multiplexer. Whatever the given multiplexer is 2 by 1 multiplexer, take the 2 by 1 multiplexers. If you take the 2 by 1 multiplexer, take 2 by 1 multiplexer. Is it required? Is it space is enough? Okay, I will take horizontally. Okay, let us take this one. 1, 2. Okay, so we will take this. And also, what is important thing is that while calculating this process, so this is the first stage. The number of 2 by 1 multiplexers are required in a first stage is 8, and this is the second stage, and this is the third stage, and finally we'll get the fourth stage. In the fourth stage we'll connect a 2 by 1 multiplexer. So it has 4 stages of multiplexers. In the first stage 8 2 by 1 multiplexers are arranged in a column wise. So let us see that. So yes, enough from left to right is enough to draw. So take the 8 multiplexers. Four, 5, 6, 7, 8. So these 8 multiplexers then connected to it is a 2 by 1 multiplexer. You may take this one 2 inputs. Each one required 2 inputs. Can we call it as unique numbers, unique names? Of course, individual multiplexer having its inputs are I0 and I1, but we can consider as unique names. So we can take this one I0, I1, I2, I3, I4, I5, I6, I7, I8, I9, I10, I11, I12, I13, I14, I15. So I15. So it is a 2 by 1 multiplexer. It has one output. Each 2 by 1 multiplexer has only one output. You remember that this is a 2 by 1 multiplexer. And then, so if it is a multiplexer 2 by 1, definitely it has select lines. 2 by 1 multiplexer require one select lines. Let us take the select lines. Take the select lines. Take the select lines. S naught is the select line. So this it has common select line. I am taking that select line as S naught for all. Same select line S naught. And then what is our second stage? Second stage require 4 multiplexers of 2 by 1. So take that one, 4 multiplexers. 1, 2, 3, 4. So by connecting these two, we can take that one. Input, output. This is also 2 by 1 multiplexer. 2 by 1 multiplexer. This 2 by 1 multiplexer again having select lines. These select lines I am taking just one one of the select line input like S1. If I am taking as S1 this one, so connecting common to all. Select line. Again, the third stage require only 2 by 1 multiplexer. Take this one, 2 by 1 multiplexers. By 1 multiplexer, and select lines I am taking this one as S2, which is connected to common for the both. Otherwise, in order to avoid this confusion, I am taking same name S2. So these two are connected at final stage, require only one 2 by 1 multiplexer, which is called actually Y. You can take this select line as a S3. So this is what 16 by 1 multiplexer using 2 by 1 mixer. If you see this mixer, how many inputs, primary inputs? The primary inputs are I0 to I15. I0 to I15. And I0 to I15. So then these are 2 by 1 multiplexer. And primary output is Y, single output. So it is like a simple 16 by 1 multiplexer, like I0 to I15, one output Y, and the select lines are S0 to S3, 4 select lines. Let us check with one example by giving select lines whether this 16 by it will act as a 16 by multiplexer, 16 by 1 multiplexer or not. Let us see one. I'll take some color, different color pointer. I'm taking this one. For example, S0, S3, S2. If I am taking 10, 10 is the inputs. 10, 10 are the inputs. So if I am taking 10, 10 as inputs, what if S0 is equal to 0? If S0 is equal to 0, so all the F0 is equal to 0, this is the path. I0 here, I2 here, I4 here, I6 here, I8 here, I10 here, I12 here, I14 here. But what about S1? S1 is equal to 1. S1 not is equal to 0. It selects all the first path signals. So it like this one. What if S1 is equal to 1? Even if F1 is equal to 1, only this path is selected, which allows only one path among two. So I2 is available here, I6 is available here, I10 is available here, I10 is available here, like I14 is available here. So S2 is equal to 0. When S2 is equal to 0, the first path is selected in this among 2 by 1 multiplexer. S2 0, S2 0. Then this path is selected. Then I2 comes here. Then this one, S2 is equal to 0, I10 comes here. When this I10 comes, I2 comes, that will connected available here. So I2 and I10 are available. And when S3 is equal to 1, this is the second path is selected when compared with this first. So here it is I0 and I1 internally, or otherwise first and second path. So there are 2 by 1 multiplexer. S3 is equal to 0, second path is selected. If S1 is equal to S3 is equal to 0, first path is selected. So in this case, this path is selected. So second path is selected, that is connected to this output. So you get finally I10. So which is equal to 1010 means the among 15 inputs, I10 is selected. So the output will get I10 only. So the path is like this. The actual path for this one is this I10 is passing through different stages of muxers. You will get the I10. So in this way, there are total 16 I0 to I15 inputs. So if we design the 16 by 1 multiplexer higher muxer using 2 by 1 multiplexer, if we are given some check with this input 1010, so it will select 1010, which is nothing but I0 input is selected to the output. So in this way, we can implement the multiplexer. If you see this another example, second example, what has given the given muxer is 64 by 1 muxer, but we have to implement using 8 by 1 multiplexer. There are two stages, first stage and second stage. In the first stage require 8 multiplexer, in the second stage require only 1. So let us see those. One, 2, 3, 4, 5, 6, 7, 8. 8 each muxer having 8 by 1 multiplexer. So in order to reduce the number of channel, I just put like a bus. What is the bus? First bus having inputs are I0 to I7. Next input is I7 to 15. I15 to 23. I think. I24 to 31. I31 to 38. 31. 38 something. I39 to 40. So finally you will get 63. I63. 8 we can add 39 to 47, I47 to 55, 55 to 63. So this 8x1 multiplexer connected with the 8x1 multiplexer. It has two stages. So this stage connected with the 8x1 multiplexer. If we take 8x1 multiplexer, then you'll get again 8x1 multiplexer, you'll get out. So in this, the first stage has 8x1 multiplexer, and the second stage only 8x1 multiplexer, so that the total inputs are I0 to I63 under one single output. The select lines, if you see the select lines, I'm taking the select lines. Here it is S0, S0 to, it is a 8x1 multiplexer, means taking three inputs S0, S0, S1, S2, 3, S0 to S2, S0 to S2, S0 to S2. Like that we can take S0 to S2. The remaining, this one, this remaining higher order select lines are S3 to S3, S4, S5, S3, S4, S5. If I am taking any value from this one, S5, S4, S3, S2, S1, S0. So I am taking, for example, 1 all zeros. So first three bits S0, S1, S2 all is equal to 0. When it is 0, among 8, the first input is coming, I0 is coming, I7 is coming, I15 is coming, sorry, it is I8, and it's taken 8 to 15, 16 to 23, 24 to 31. Here it is. '38, 39 to 47. '46, 47 to 54, 55 to 63. So here it is. I'm taking 16, I8, I16, 24, 32, 39, 47, 55. So again, if you take this one, one double zero, triple zero. So here in this S5 is equal to 1, S3, S4, S5. So S5 is equal to 1. Then we can take only one triple zero. S3, S4, S5. S3, S4, S5. S5 is equal to 0 means 0, 0, 1. 100. Then we can take that one is, this one is 5. So in this case, that one is we can take S0, S1, S2. 0 means all the lower ones are coming. All 0 first one is coming. Here this first one is 55. The next one is, it will take the 100 means 4. The remaining thing is that fourth one, 1, 0, 1, 2, 3, 4. Here it is 32. I32 is passing through this. So I32 is selected. So this means that S5 1 remaining all at zeros means I32. In this way we can design the 64:1 multiplexer using eight by one multiplexer. So this is one way to implement higher order multiplexer using lower order multiplexing. The second way is, the second application of this multiplexer is, you can implement, it is like a universal logic gate. You can take Muxer 2:1 multiplexer, you can take any gate. For example, if I am designing, for example, AND gate, y is equal to a and b. You know the truth table for AND gate is a, b and y 0, 0, 0, 0, 1, 1, 0, 1, 1. You will get all zeros, only 1, 1 for 1. So if you take this one, it is select lines. If I am taking A is a select line, zero, 0, 0, 0, 1, 1, 1, 0, 2, 3. So if I am taking this way, what are the combination that will get the logic one is nothing but 3. So you can circle with those one. Then we will get both uncircle will get 0 and then A. So I0, if it is I0, I1, we can take ABR inputs. So take A is a select lines. If A bar it is connected to, let B the select line, and one thing is 0, another thing is connected to A. So this way you will get a AND gate out. And we can, if you want to implement anything, you can take that example, take the expression for the 2:1 multiplexer, For example, S bar I naught, S I1. You can connect in this way. So if you want to select lines, for example, S is equal to 0. If you take that is I naught 0, I1 1. When if it is 0, entire thing is 0, I1 is 1. Like no select lines, S select line, I1 is equal to 1. If I am connecting 0, 1, whatever it is, if you connected A, for example A, the output is simply, if A is equal to 0, you will get 0, A is equal to 1, you will get 1. Like so. The third way is we can implement this multiplexer using implement the Boolean function using multiplexer. This is one diagram for 4 by 16 by 1 multiplexer using 4 by 1 multiplexer. If you take the formula, same formula, take the 16 by 1 multiplexer, higher order multiplexer divided by that what we are going to implement with a simple basic multiplexer is 4 by 1 in this case. So take that one, divided by 4 means you will get 4. Again take that 4 divided by 4, you will get 1. So first stage, it has 4 by 1 multiplexer. The second stage has only one multiplexer. So there are 4 different 4 by 1 multiplexer. And if it is 4 by 1 multiplexer means 2 select lines. Take the lower order select lines S1 and S0 and take the higher order select lines S2 and S3 here. So among this output of these 4 multiplexers connected to 4 by 1 multiplexer, you will get output Y. So that inputs are 16 and output is 1. And third way of implementing using multiplexer is implementation of given logic expression using multiplexer. Let us implement the given Boolean function is this one, a 3 variable Boolean function. F of ABC is equal to sigma of 0, 1, 4, 6, 7. So here it is, remember that focus on that order, which order you have to take, which variable you have to take the control signal or select lines. So if I feel that A is a select lines, higher order variable is select lines, the B and C are the inputs. So then we can implement so basically it is a 3 variable function. It is a 3 variable function. We can implement 2 power 3 minus 1 multiplexer by 1 multiplexer. So here it is nothing but 3 variable means 2 power 3 minus 1 means 2 by 1 multiplexer means 4 by 1 multiplexer. We can implement this Boolean function using 4 by 1 multiplexer. So take the one variable, the most significant variable, the higher order variable is like a select lines and A, B, C are the prime data inputs. Okay, in this case, if I am taking that a table, the multiplexing minimized table, like take the table in this way. If I am taking A is a select lines, so I am taking A bar and A, and B, C are the data inputs. I am taking 4 by 1 means 4 by 1 means 4 inputs, I0, I1, I2, I3. It is a BC. BC means 0, 0, B bar, C bar, B bar C, BC bar, BC. So A bar, B bar, C bar, we can take 0. And 0, B bar, C bar, 0, 0, 1 means 1. 0, 0, 1, 0 means 2. 0, 1, 1 means 3. A means uncomplementary means 1. B bar, C bar means 1, 0, 0 means 4. 1, 0, 1, A, B bar, C is 5, 4, 5, 6, 7. Take this way. Again, after that, we can circle of the min terms which are given in the problem. What are the min terms given in the problem is 0, 1, 4, 6, 7. If you circle those minterms which are given in the problem, I am circle 0, it is given in the problem. 1 is given in the problem. 4 is given, and 6 is given, and 7 is given. Okay. In the column wise, whatever if both minterms are uncovered by the circle, then we can take it as a 0. If both are covered, we can take it as 1. If any one covered, that corresponding row variable, selected line variable is taken as input. So here it is, both are covered, we can take 1, and this one circle is covered, we can take that one is A bar, and here it is 6 is covered, that row is called A, and 7 is covered, that row is called A. Take this as a data inputs, and the control signal is B and C. If we draw this diagram for this one, draw the diagram for this one. A multiplexer, 4x1 multiplexer implemented for this Boolean function. 2 inputs B and C, 4 inputs I0, I1, I2, I3. If one first I0 corresponding input is 1, I1 corresponding input is A bar, I2 corresponding input is A, and I3 is A. These two are connected to A. Okay. For example, if I am check this one, Y output, let us take B is equal to 0, C is equal to 0. When B 0, C 0, it is selected to 1, logic 1. So that output is 1, Y is equal to 1. So it is 0, the minterm for logic 0, it is 0. 0, 0. So for example, A0. In the truth table, A0, B0, C0, you will get 1 because that's why minterms is presented in the Boolean function. So A0 means here it is 0, 0, 1. So but it selected 0, 0 means this one is selected 1. For example, 7. If I am taking 7, B1, C1, A1, 1, 1, 0, 1, already 1. So 1, 1 is given. So 1, 1 means I3 selected. So this one is passing through the 1. So output is 1. So 7 is already in the minterm. So its corresponding output is logic 1. So in this way, we can implement a given Boolean function for the given Boolean function into multiplexer. Again, if I take this multiplexer, let us take here it is A as a input and BCD as a select lines. Take that one. I0, I1, I2, I3, I4, I5, I6, I4. I5, I6, I7, 0 to 7. Okay. So then I am taking A bar and A are the inputs. So BC, if you take that one, order 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What are the minterms given in the problem? 0 is given, 1 is given, 3 is given, 4 is given, 8 is given, 9 is given, 15 is given. If you find out that column wise, if both digits are minterms are circled, we will get 1. Both circles will get 1. No circles in this column, 0. Here it is only one circle. Its corresponding interval is A bar. Here it is A bar. Here it is 0, 0, A. So your multiplexer now, if you take this one, the 8x1 multiplexer, if you take a 8x1 multiplexer in this case, if I am taking 8x1 multiplexer, 1, 2, 3, 4, 5, 6, 7, 8 by 1 multiplexer. The three inputs are B, C, D, and A is the remaining. These are the data inputs. Data input is, first one is 1, 1, 0, A bar, 0. Like you can connect it like 0, otherwise you can take 0, 0 and A, so that you will get implement this one 8x1 multiplexer. In this way, this is the third application of implementation of multiplexer. Now similarly, we can apply the same thing in a demultiplexer. Whatever the problem given in the demultiplexer, again if you apply the reverse case, you will implement the demultiplexer. So these are, I am taking these problems from the lecture notes from the IARE and then Maris-Mano, Digital Design by Maris-Mano, 4th edition 2006. So in this way, we can implement a multiplexer of a given higher order multiplexer using the lower order, or you can implement any Boolean function or any logic gates using multiplexer, or the given Boolean function implement using multiplexer by the minimization table, the like multiplexer table to implement the multiplexer for a given Boolean function. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.